Right, let's crack into it. Now, guess what? We have a set screw, that's right. And it's got on it a stamp on the top of it there. And that gives you some critical information. It's metric, 8.8 to be precise. There are generally 3 primary high tensile references, 8.8, 10.9, and 12.9. There are a few others, but they're the main ones that I work with in my engineering work. And that one there, now the thing about this is you see how it's got a thread from end to end? It's not a bolt. That's right. Have a look at that. If that was a bolt, it would have a blank shaft right the way up to about there, okay? And why is that? Real simple. You see, that diameter there, from side to side there, it's about 10 mil, right? Okay, you take that, times it by 2.5, I can't quite do that, and that amount of thread will be there, okay? And that'll be blank, and that'll be there, and that'll be blank, and that'll be there. And that will go wee up the other end here as the end of the bolt continues. So if you want a 100 mil bolt, 150, that amount of thread there will still be up this end. It'll still be just a bolt, okay? That there is the critical difference. Now this here is metric, okay? Because you can tell by the 8.8, that is the defining quality of metric. Each of those there, those tips there, are about, for 10 mil, they are 1.5 millimeters apart. You can get a little vernier and go tick, 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 and you'll find that they're measured exactly 1.5 millimeters apart, okay? Because a M12 is 1.75 and an M8 is 1.25. It's called coarse thread. Now, with that also in mind, okay, this one here comes in generally 2 other threads, but what you're looking at there are 2 really critical pieces of information, right? And secondly, that whole thing there is a set screw, not a bolt.